In this video, I'm going to talk about angles. I'm going to show you how to convert angles from radians to degrees and degrees to radians, as well as how to find coterminal angles. When we convert angles, we're going to use a ratio or a fraction to change from radians to degrees and vice versa. Pretty much there are different ways to measure angles, degrees and radians. There's also more ways to measure them, but this I'm going to focus on radians and degrees. It is pretty much very similar in converting from meters to miles, or vice versa, miles to meters. All right, but in this case we're dealing with angles. So in one full turn in a circle, there are 360 degrees. And in one full turn, it is when measured in radians, it is measured as 2 pi radians. So we're using a fraction. So this fraction is going to be 360 degrees over 2 pi radians, which reduces into 180 degrees over pi, or 1 pi radian. This is to convert from radians to degrees, and vice versa. If you're starting off in radians and want to end up in degrees, you're going to start off with 2 pi over 360. If you forget what numbers there are, that's the reason why I provide the full circles. But if you remember to the reducing side of it, we have pi radians over 360 degrees. And I forgot to put radians right here. So this and this is going to be the main ones that I use, and they are derived from this. There is nothing wrong with you to start off, or use, I should say, this, either of these two fractions or ratios to convert. So in the first example, I am asked to convert the degree angle, or the angle in degrees, into radians. So I have 325 degrees. I'm going to put it over 1 to make it easier, multiply with the fraction. I am starting off with degrees. I want to end in radians, so that means my numerator has to be radians, my denominator has to be degrees. How many radians are in how many degrees? Or how many degrees are in how many radians? They are 180 degrees in 1 pi radian. When we multiply this out, we are going to get 325 pi radians over 180. All right, this degree and this degree reduce each other out. I'm left with radian. When you simplify this out, so this becomes 65 over 36 pi radian. If you want to multiply that out, more than likely you're not going to be asked to multiply that out, but that is approximately 5.6723 radian. In the second example, I'm asked to convert the radian angle to degrees. So now I start off with this, and we are told this is in radians. And we're going to multiply that by our conversion. Radians need to reduce out, so radians in the bottom, degrees in the numerator. There are 180 degrees in 1 pi radian. So what happens here is pi's reduce each other out, so the radian When you multiply this out, we are going to get so far negative 4,140 over 12 degrees. Let's simplify this out and divide out, and that is going to be negative 345 degree angle. So that's pretty much how you convert from radian to degrees using 180 degrees over pi radian. Or if you want to go from degree to radian, we're going to use pi radian over 180 degrees. Coterminal angles are angles that when you start in standard position, you're beginning at the positive x-axis, and they have a common ending. So what that means is we're going to have here's my x-axis, here's my y-axis. I need more detailed, right? Axis. When we have an angle that is measured, let's say that is 43 degrees. This is an angle in standard position. It begins on the positive x-axis. We're going to find another angle that has this same common ending, or this common ray, that still starts at the x-axis. So if this starts at the x-axis, all this in red is said to be a coterminal angle. As well as if it starts here, the x-axis, this green angle is also a coterminal of 42 degrees. The only fact is that this green is going to be negative measurement. What are those answers going to be for these two coterminal angles? So we have 43 degrees. What happened to this red one? What did I do? I actually made one full turn compared to this 43. So I am going to be adding 360 degrees to that. So that makes this red coterminal angle at 403 degrees. So this is 403 degree angle here in red. Right, because it's 360 from x-axis to x-axis plus the 43, which is 403. For the other coterminal angle, right, it begins here, and it begins here at the x-axis, it ends here at the blue. It's not full 360 turn, so in order to do that, essentially what you're still doing is you're kind of doing this. We have a negative 360 angle if it were to be a complete turn, but it's missing 43 degrees, which is this positive 3. So in a way, we're just doing 360 minus 43, and that becomes 317. But this is negative degrees because this is, again, going counterclockwise. I'm sorry, clockwise. So we are either going to add 360 degrees to find a coterminal angle, or subtract 360 degrees to find a different coterminal angle. So we're going to find a coterminal angle that is both positive and negative with 55 degrees. So in order to do that, 55 degrees is positive. So I'm going to add 360 degrees to that, and I get 415 degrees. Here's one positive, or the next positive to be more specific. 415 is the next positive angle that is coterminal to 55 degrees. To find the negative angle, this is positive, I am going to subtract 360 degrees with those 55, and that gets me negative 305 degrees. So these are our two angles that are coterminal with 55 degrees. One is positive, which is 415, and the other angle is negative, which is negative 305 degrees. Now we're going to find a positive and a negative angle that is coterminal with pi over 3 radian angle. All right. In the previous ones, we added and subtracted 360 degrees because the angles were in degrees. Right, that is one full turn. How many radians are in one full turn? There are 2 pi radians. So instead of adding and subtracting 360 degrees, we're going to add and subtract 2 pi radians of an angle to this here. So this angle, pi over 3, is already positive. So I am adding 2 pi to that, all right, over 1. So I need a common denominator. So this is, I'm going to multiply this by 3 over 3. So I have pi over 3 plus 6 pi over 3. Now that I have a common denominator, 1 plus 6 is 7 pi. Here is my positive angle. Again, very similar. Now I'm going to subtract pi over 3 minus 6 pi over 3. So instead of adding, I'm subtracting compared to this one. 3's remain the same for the denominator. 1 minus 6 is negative 5 pi. So the two angles that are coterminal with pi over 3 are 7 pi over 3 radian and negative 5 pi over 3 radians.